Okay, so we're going to do some law of sines and cosines examples from the homework. I'm going to do one problem from each of the assignments. So here is our first assignment, number 8, out of the 45 I'm asking for this week. We have a given an angle with 30 degrees, B, angle A with 100 degrees, and B with 6. So little b. So I'm not even going to draw a picture. I don't think it's necessary. I just want to know that this B matches that B. So I know I can use law of sines. So I'm going to jump down here and say law of sines is the sine of A, capital A, over little a, sine of capital B over little b. So I'm going to write that out here. Sine of A over A, sine of B over B. So that's what the law of sines says. So now let's cross multiply, and I'm left with A times 30 degrees, sine 30, and then 6 times sine 100. And if I divide that 30 degrees over, and I get 11.818 is my answer. So hopefully it matches your answer. Let's move on to number 20 of the second homework assignment. This one is a law of cosine section. So I'm given a capital C, the angle, and I'm given two lines. So it's kind of like a side angle side problem, but I don't have a matching capital A or capital B, or I don't have a matching little c, so I don't have law of sines available to me. So I have to use the law of cosines. And the law of cosines is this right here. Now check that out. I wrote it down when I did it, and I tried it, and I got a wrong answer, and I was thinking, what's going on? But it's because I forgot the cosine. So I have to put the cosine in there. So c squared, in this case, I need to see the c. A squared plus b squared minus 2ac, 2ab, cosine capital C. All right, so let's plug in everything, and I noticed that little c is going to be square rooted. So 13 is a squared, and 9 is b squared minus 2ab cosine 62. I put that in my calculator, and I get 11.838. Not bad. All right, so did it match yours? All right, last one on the word problems. This one was requested of me, so here's my graph, or my picture so far. So we have an airplane, and it's got an angle of elevation of 11 degrees, this is number 36, to the airport. So there's my big triangle right there at 11 degrees. I don't know anything else. It's just 11 degree angle depression. And then it flies the same altitude, 5,000 feet horizontally, and now the new angle of depression is 16 degrees. And that's all we know. We know 11, 16, and 5,000. So let's figure out what I do know after that. So these two things is what I do know. I do know that this angle right there is 180 minus 16, because that's called supplementary angles. So it's going to be 164 degrees right there. And if that's 164 and that's 11, then what's this angle right there? Well, that's going to be 5. So 180 minus 11 minus 164 is 5 degrees. So now that I have this angle, which is opposite that 5,000, and I have this 11, which is opposite this x1, the hypotenuse of this next one that we need to figure out. So I need to use the law of sines. So here's my law of sines. We have sine of angle 5 over 5,000, and then sine of angle 11 over this x1 here. So law of sines first to figure out this hypotenuse of this triangle that we're trying to figure out. And after I cross multiply and solve for x1, I get that x1 is 10,946, 43849. I'm not going to round it yet because I'm not done with it, the problem. So that's the hypotenuse, and I have the angle, and opposite hypotenuse is tangent, or sorry, sine. Sine is the opposite over hypotenuse. So I'm just going to use a basic SOHCAHTOA problem here. And I see that if I cross multiply this x1 and sine 16, I get 3,017 feet, 2.247 feet high. That would be my altitude. So I hope you got those answers, and we'll look forward to seeing your work.